Hello and welcome back to the attic. As you can see, sometimes it's a mess up here. And what you can also see is it's not very bright. I had this light over here that I fixed it up to work on 30 volts. That little black power supply right there is a 12 to 30 volt converter. I got a bunch of them. I have absolutely no use for them, so I thought, hell, I'll make this lamp work. And now I know why it was in the free bin at a garage sale. It works for a while, and then it goes dim. And then it'll come back. So I was going to make a little wood fixture so that would shine down, just for doing videos and stuff. And what I have is this shop light over here. I bought a couple of these thinking I was going to modify them. And I had opened it up and it took 70 volts, and that was last year. Never got around to it. So actually the reason I'm up here is that I was trying to find, I bought a TV and it's 120 volt, and I have this little power supply that the H bridge went bad on it, and so I converted it so it was like 150 volts, and then I did a voltage doubler which added another 25 or so volts, so it was like 170 volts DC, and that runs TVs and stuff just fine. But somehow it was up here and now it's not up here. I never moved it. So, but anyways, let's get back to this lamp. So it's got a little power supply over here, and the covers just sort of snap off it, and I'm going to show you how I discovered how to make this work on 12 volts. So I never actually counted the number of LEDs, a lot of them. Who can count that high? But I knew it was somewhere around 70 volts, so I thought, well, I'll just tap off half, and then I can run it on this supply, and I'll just put the two halves in parallel, and I'll get 30 volts. It'll run on the supply fine. But then I tried hooking it up, and I found that like it lit up less than half of the supplies on one row. And so what I've done is, if you look over here, is that I have this little probe voltmeter, and you can see I got 29 volts on here. So I started probing around. So the first thing when I hit, 5 LEDs light up. 10, 15, 20, and so on. And I found that 25 LEDs gave around 13 volts. And if you really wanted to drive this thing as a shop light to get the most brilliance, you'd want to have 4 LED sections. And that gives you about 10.5 volts, and then you have a dropping resistor, and make the thing run. But I'm using this just for photography, and I'd like a wide light, and it doesn't have to be really bright because it can be too intense. So I'm going to do 5 LED groups. And what I've done is right here, you can see where the trace is. I broke this connection between the two. So this next one, I'll bring back down to negative again, and I can go up with another 25 LEDs and break the connection again, and I keep going the whole way. Now that gives me a few short at the end, and I can, put a little resistor in series to drop the current, so it'll light up the last few. I think I can do 4 at the end, or whatever. Who knows the math? But anyways, that's how you can do it. This is really a neat idea. Take a probe. Now this isn't really a sharp one. There are some probes you can get that darn right lethal, and but you can generally hit the side of an LED. And with a 1.5K resistor there, you're not going to do a lot of damage in current or anything. And you can investigate. you know, sometimes these LEDs are put in series and then in groups. Sometimes they're in parallel. But yeah, it's just kind of interesting. And now I don't need any kind of converter or anything. It works on 12 volts. I can move it to someplace else where I'm working and just plug it right into my house, any outlet. So that's it. I just thought this was kind of interesting, this whole method of diagnosing it. And, you know, just having a probe with a resistor in series, because it takes very little to actually light an LED. And like, normally they'd be, see, this is two of them in series, that's 5 volts, 5.19. And that's at basically the Zener voltage. You can drive them a little bit harder, but if you reduce the amount of current into an LED, it's far more efficient. You just need more of them. I don't know if any of you have heard of Dubai lights, but Philips made this light specifically for Dubai. One of the crown princes or whatever was really high on energy savings. I don't know why. They got all the oil in the world, but their LED lights are twice as efficient as the ones that you buy here in the United States. And I saw a video up, maybe I'll put a link to it. It's about, this guy tested about 40 LED lights to find which ones had less flicker, which ones had better color purity, a lower, most all the LEDs make blue, and then this little phosphor there converts it over. But they all have this little blue spike, and that's what a lot of people don't like. And they said that the Philips, there's one, a color tone one or something like that. But anyways, it's only $3.50 each. And I just went to Lowe's, I think, or Harbor Freight, Lowe's or Home Depot. And they had a bunch of Philips, but they didn't have any of these lights. They had a bunch of the other cheap ones. And a lot of the lights are really kind of bad for flicker. But these Philips, they compared to a real deluxe light that was $22 each. And so for you to have your inverters that are flickering and stuff like that, look for the Philips. And it should be about $3.50. It should say something like pure color tone or something. But that's it for LEDs. So thanks for watching.